And hello, John.
How's it
Welcome,
going?
John. Welcome, John, to AWS On Air. And John, please do let us know who you are, what do you do, and why should we care?
Well, I don't know about the why should you care part, but I can tell you who I am. I'm John Fritz. I run the product management organization for our memory database and caching services. So Elasticache and the newly announced MemoryDB.
So
Welcome.
I am super excited about this launch because I am definitely a big fan of Redis, and hearing that there's a new way to do Redis in the cloud, it has me excited. So I want to know more about what MemoryDB is. So give us your pitch. Like what is MemoryDB?
Yeah.
Yeah, well, so kind of a high level, MemoryDB. It's a Redis compatible, durable in-memory database service. Delivers ultra fast performance. That MemoryDB is fully compatible with Redis, which as you know, as a Redis fan, but for everyone else out there, Redis is an incredibly popular open source in-memory data store that enables you to use data structures to kind of easily build applications, and actually was recently voted by Stack Overflow developers for a fifth consecutive year the most popular database. That says something just about its popularity. So MemoryDB, 100% compatible with Redis, enabling customers to build applications utilizing Redis. And the same Redis commands they use today. So if you do have an application and you want to kind of migrate it over to MemoryDB and see how it works, you can just migrate it and it'll work. With MemoryDB, all the data is stored in memory. And that's super important because it's all about performance. It enables microsecond read latency and single-digit millisecond write latency, and incredibly high throughput. It's kind of the same things that you'd expect from Redis. But also what makes MemoryDB one of the kind of the innovation points here is that also the data is stored durably in a multi-AZ transactional log. So that means that you get this kind of in-memory performance combined with multi-availability and durability to create kind of a high-performance database that you can use as a primary database, the foundation for your application. Yeah, I guess that's a quick high-level overview of what it's all about.
So
John,
this sounds amazing. I want to say what you said earlier about Redis being on top of the Stack Overflow rank for 5 years in a row. That's absolutely amazing, and I can believe it because I know I personally have used Redis in pretty much every major project I've built over the past 10 plus years. But I know there's a lot of people who maybe they're new to databases, new to the cloud. Maybe they're not sure what Redis is. And I thought maybe we should take a step back and talk about
correct.
what is the benefit of the in-memory database. Why exactly is it so popular? When I'm considering Redis, like I see MemoryDB, I know that Redis is popular now, but why is it popular? Why would I want to use that in my architecture?
Why people use in-memory databases? Let's explain to me. I don't know why.
Yeah, well, kind of at a high level, and there's a bunch of different in-memory technologies out there. Redis obviously being the most popular based on a lot of these metrics, but it comes down to really why is Redis so popular? Why is there just kind of this cult around Redis? Well, one reason is just performance. That performance matters, getting down to microsecond read latency, single-digit millisecond write latency. That matters because applications today, they're interactive, right? When you're on an app on your phone, you need things to happen fast, or better yet, most applications that are being built today that are net new, and a lot of old applications that are being ported are adopting microservices architectures where you've got for every application, a bunch of components. Why are people doing that? Enable you to move faster, build quicker, and kind of iterate at a faster pace. But for every kind of set of microservices you have, now there's all these communications between them, meaning one user action might need to invoke a ton of different services under the hood. So what all this kind of turns into is you need a high throughput, hot data tier to be able to back kind of modern applications today, especially ones that need to scale. So in-memory technologies is an obvious choice. And people today are using Redis primarily as a cache in front of kind of a durable data store. That's one reason. A second reason for Redis is just the ease of development that Redis utilizes. It's not just a key value, obviously it's a key value store, but it utilizes data structures to be able to kind of more easily build applications without having to write as much custom code in your application. Like the canonical example is a leaderboard, or Redis has a sorted set where you can easily order things from within the application versus needing to do all of that logic outside of the client. Also, there's like geospatial lookups. There's all sorts of things in Redis that really make it easy to build with, and that's another reason why it's just so popular to use.
Yeah, I remember some of the things I've built over the years. One of the classic ones was we need to build rate limiting for authentication attempts. Like, you don't want people to just be able to hit the API and auth over and over again, like try to brute force a password. So we were able to use those in-memory data sets to implement a little token bucket that would keep track of number of attempts per user login. And so we could rate limit, slow down, or like return a response being like too many login attempts on this particular account within a particular period. And then Redis also has that capability to expire, so you can make the tokens expire at a certain time. And so that made it super, super easy to implement rate limiting to stop people from brute forcing passwords.
Yeah. Now, there's been a couple of comments here in chat, right? So people are asking, is this now generally available? Is Amazon MemoryDB, can they go and use it now?
Yeah, absolutely. We launched it yesterday in the AWS Innovate keynote, and available in 4 regions, I believe. US East 1, Dublin, Brazil, and Bombay, and we're kind of rolling it out to more regions.
So make sure to check out, if you're interested, Amazon MemoryDB is available for you right now in those 4 regions. So North Virginia, Dublin, Brazil, and Bombay. Check those things out. Check the MemoryDB out if you want. And yeah, chat, let us know. Tell us, are you running in an in-memory database? Are you running Redis? Are you running Memcached or something similar? Do tell us if you're using it and how you are using it as well. John, is this product, so Amazon MemoryDB, right? How does it relate to Redis Core? Is MemoryDB based on Redis Core?
Yeah, great question. And yeah, it absolutely is. That it's Redis compatible database. We're in AWS kind of going back. We've worked with Redis and worked with the open source Redis community for over a decade now with our caching service, Elasticache, for Redis. And actually, one of the 5 main contributors on the governance board is part of the team. So we've been very close to Redis open source for quite some time. MemoryDB is kind of just another product around Redis, where we're using Redis, but some of the areas around, say, durability with this multi-AZ transactional log and a few other areas are things that are kind of different from how open source Redis would do some of these things. But this is definitely a part of the Redis ecosystem, and we're using that project.
Yeah.
So that sounds interesting to me. You said there are some differences around the durability, multi-AZ. Let's zoom in on that, because assuming I am familiar with Redis, and I kind of know a little bit about how it's worked in the past. I remember with Redis, I had to do basically like backup with what's called like an append only file, and so like every few seconds it would take a transaction log of all the operations and kind of compress it down to disk, and periodically you would have to compact that file down. But there was always a risk that if my Redis server restarted for some reason, I could lose like a couple seconds of data that I had put in there. So that was always a little caveat that kept making me like, should I use this for durable data? So my understanding is MemoryDB does this differently. Maybe you want to talk more about that.
Yeah, for sure. And I think that's a critical component when you think about kind of a primary database that you're going to use for an application. Not losing data is generally an important part of that decision. That's actually one of the reasons that we built MemoryDB in the first place, that we saw, customers loving Redis, right? The performance of Redis and the data structures and the Redis APIs through Elasticache. And as I said, we've been running Redis workloads, working with customers running Redis for many, many years. But this was kind of a sticking point where people say, hey, we'd love to do this, but we're not really happy with what you've described, the Redis append-only file open source system for kind of a quasi-durability solution. And so, you described AOF pretty well. It's a file that's run basically on the local disk of the primary, where writes are appended to that, and theoretically you can recover from that. The problem is if that node goes down or other things happen, that data is lost, right? Or if that node goes down before it can replicate out to other nodes, then data is lost. There's a couple of failure scenarios that are pretty nasty that could occur using that. So we do it a bit differently. What we do is we use in MemoryDB a lower level component that is basically a durable transaction log that's run under the hood across multiple AWS availability zones. And that's basically serving as, and kind of this is a common practice in database architecture to have things like this, durable write log, where when a write gets written to MemoryDB, the write isn't act until it's stored durably. So if, there's a failure anywhere, no data is going to get lost. And another kind of component of that is that, we can run a cluster with read replicas. This system guarantees the delivery in a consistent way to all those replicas. So that other scenario I brought up with AOF, the append-only file, that could go down. You could lose the propagation of records. In this case, when a record is written, it's durably stored and it won't get lost. So, I'd say that in and of itself is a major thing when we talk to customers on, say, hey, what's important here in a primary database. That's a pretty important thing, and having a kind of bulletproof system to deliver that guarantee is critical.
So the amazing thing that I'm hearing here is that I can actually use this as my primary database. I wanted to highlight this comment from Mario earlier, where he said, we're using a cache behind a Heimdall data cluster to offload SQL loads. And this is traditionally, I think, how a lot of Redis usage has been in the past, which is like you have a different data store. You have your SQL as your durability, and then you're using Redis as a cache in front of that. But now I don't have to say Redis is just a cache anymore. Now I could actually use Redis as my primary data store with MemoryDB.
Yeah, that's correct. And I mean, I think, we're going to see both use cases that, we love Elasticache for Redis. And, for those of you who don't know what Elasticache is Elasticache is a service we have that, provides a cache using either Redis or another open source engine, Memcached. And, there's a lot of other great databases. And if you want to accelerate data access or kind of get higher throughput out of them, putting a cache in front of it is quite a common practice. I think for some use cases, though, it'll make sense that you want to run, the problem with having a cache in front of a database is there's added complexity in managing the cache, cache validation, that sort of stuff. You have two systems. It just adds more complexity. MemoryDB, for use cases where it makes sense, you can just run that and it gives you, cache-like performance. Although, I do want to point out that Elasticache from a write perspective gives you millisecond write performance. MemoryDB is single-digit microsecond. Opposite. Cache gives you microsecond. Yeah. MemoryDB gives you single-digit millisecond performance because of some of the kind of things I described around utilizing that transactional log adds a little bit of latency. So, for those kind of cases, the cache might make sense. But what we found is that there's a ton of use cases, building microservices applications, that sort of stuff, where these sorts of performance guarantees are right within that range. And with MemoryDB, you can simplify architecture. You've got one database that can serve as the foundation for your app. It's durable, high performance, and gives you the Redis, gives you Redis to more easily build those applications without creating the cache in a primary database.
We have a great question here from Christian coming in. So, what are the throughput capabilities on high load when it comes to MemoryDB? Right? What are the transaction isolation?
Yeah, so the throughput capabilities on high load, we've got some of this written on our website. It's basically the same as Redis that you can do. I think hundreds of thousands of transactions per second. Now, obviously you can saturate each node of the cluster. So one cool feature about this, similar to Elasticache, is that it's quite easy to scale. So if you find that you've hit the limit of, say, a read node, you can create up to 5 read replicas across different availability zones for each shard. So, MemoryDB is a sharded architecture where you have a key space and you can shard it amongst one to many more nodes. So if you need, say, more write throughput, you can create more shards. But if you have a shard that says you need to really crank the transaction throughput, you can add more. I mean, generally, I think it's about a throughput of a node, about 100,000 writes per second, up to maybe 200,000 operations per second. It depends on kind of what the operations are and a bunch of other things. But
is there a difference? Is there a difference compared to Elasticache in this case?
From a read perspective, not really. It's the
Okay.
same sort of thing you can expect from a write perspective. There's a bit of a
There's
higher latency based on what we talked about. You get more like single digit millisecond latency versus microsecond latency that you get from Elasticache serving every cache.
So that's a good topic, I think, to chat about a little bit, like compatibility with Redis open source. Like you've talked about, there's a slight difference in throughput on writes, obviously, because we have to make these writes more durable now than they were in traditional Redis. Are there any other differences in the API? Like obviously Redis has a big API space. It just has like streams, it has pub sub, it has expiration, everything else. Is there anything else that's different about the API that people should be aware of? Or is it just generally drop-in replacement?
It's we use the Redis cluster protocol, and there are some differences between Redis cluster and kind of Redis when it's not sharded. So we use the Redis cluster protocol, and we're compliant with all that stuff. I mean, there's a couple commands around management things that we don't support, but that's because we do all that for you, like snapshotting, right? We block you from issuing a snapshot command directly because we've got fully automated backups and do all that for you. So, but kind of from the core Redis functionality, no, and we're seeing customers dropping in. There's a drop-in replacement. So it's almost like, hey, I've been running Redis and I've been using it as a primary data store, but really would prefer a more durable solution. We're seeing a lot of interest there and just kind of porting things over and getting started.
So in essence, if I'm a Redis customer, right? So if I'm using a self-managed Redis cluster on my own, and I decide, you know what, screw this, I want it fully managed. I want it a bit more durable. I don't want to think about this. It's just a drop-in replacement, right? There's no need for application code change. There's no need for any of those things to be done before I can use MemoryDB.
As far as we know, there isn't really any rough edges that we can see. I mean, if people are finding stuff, we'd love to know. We can quickly address it. We kind of see the same with Elasticache too. Tons of customers are migrating self-managed REST workloads to Elasticache every day, and so we've got a lot of experience in kind of how all that stuff might work. One thing to call out also is MemoryDB. You can easily import a snapshot, an RDB file from a Redis cluster that you're managing and kind of restore it into a MemoryDB cluster, and it just works. Or if you say are running, say, Elasticache as a primary database and decide, hey, from my architecture perspective, it might be good to move to a more durable solution. You can also import in Elasticache snapshots as well. And all that information is in the docs, relatively easy to do. And the goal is to try and make that just as simple as possible.
Just a question. I'm a newbie when it comes to in-memory databases, and I remember like some horror stories of people using in-memory databases as like primary databases for data storage, and you would reboot that database and it would just go away, right? When we talk about MemoryDB, I mean that's not the case here, right? When we talk about durable, we mean multi-AZ, highly available, etc., but we also mean your data stays where it is.
Yeah, I mean, the idea is that with once again, like, MemoryDB kind of like a database you expect that is durable, where if there is a node AZ failure, you can create for availability purposes. You can easily create replicas. Well, actually, one interesting thing to also call out, just for folks who aren't as familiar, is that when you create a MemoryDB cluster, the data is being stored in this durable component under the hood, but you can choose how many nodes you want to run. So you could say, look, I want to have availability across two AZs. You can easily have a primary for a shard and a replica for a shard, each in different AZs, and MemoryDB handles all that failover. So let's say the availability zone with your primary node gets impacted. We manage the failover where replica is now promoted to the new primary, but under the hood, you've got this durable storage system that as nodes come up, are replicating information from that. It's not like when you're running, say, a self-managed Redis cluster. If there is replication going on, it's handled from node to node. In this case, it's this kind of durable storage, transactional logs and other components that are handling all that stuff.
Awesome. We have a great question in chat here from Kessor6. Kessor, welcome back. We've seen you before on stream. Would MemoryDB support extra features from Redis, like Redis Graph, Redis Time Series, Redis Search, Gears, JSON AI, Bloom, all of these fun things? Or are these things only actually available with Redis?
Yeah, great question. And for those of you who are listening who are not familiar with some of this stuff, these are actually implemented through a feature called Redis modules, where you can basically plug in a bunch of modules. There's a few modules that are open source. There are some that are under a variety of different licenses as well, that are out there in kind of the ether of all this stuff. So right now, MemoryDB does not support modules. This is something that would love to learn more about your use case if there's any you're using. I'm not
Yes.
sure. My email is jonfritz@amazon.com. Drop me a note. I would love to chat more about it.
Yeah, make sure to give us folks like John and anybody at AWS feedback about these things. If using modules within Redis modules within MemoryDB would be something that's of use to you, tell us know how you're using it, why, etc. And then, well, any bit of feedback helps drive future directions of a service. So that is very important.
I saw a couple of people mention the stuff about Redis transactions too, and so I want to make sure that we talk a little about that because people have questions about that. MemoryDB also supports this type of workload.
Well, so there's so Redis cluster has some differences between Redis around multi-key transactions. And so, as I mentioned, we support to the degree of transactions that Redis cluster supports versus, say, if you were using Redis as like a single node with no shards, kind of the semantics around that. So, we support in kind of the details there. There's a bunch of kind of caveats around that. Happy to kind of dig into exactly how you're hoping to use it offline. Just drop me a note.
Right, that makes sense. So if you are migrating from a single node Redis, you may be using some transactions that wouldn't be compatible with a Redis cluster. But if you were already using Redis cluster and transactions, then it should be no problem. You would just have to review on a case by case basis whether your transaction was compatible with cluster mode or whether it was a single node transaction.
Exactly. That's kind of where some of and it's kind of comes up usually around into multi-key transaction. We find some of the people who really don't want to move to Redis. There's a lot of great things in Redis cluster. Right? Scale out. It's kind of the modern way in which a lot of things are being implemented in the project. But if you were using, say, multi-key transactions, and that was super important for what you were trying to do, that's where we see some resistance in moving to Redis cluster. So, happy to get into the specifics with you on if that is the case, kind of what are some workarounds, which might be something we can do in the interim. But yeah, that's kind of the summary.
But here's a good point. I think coming again back to Nathan and his expertise. What about microservices, right? Can we use MemoryDB as like a primary database in a microservices architecture due to its speed and all that stuff? Would that be a thing?
I definitely think it sounds like it would be a thing in my book for sure.
Yeah.
I think microservices, they really benefit from having that super fast data store that you can read and write from. And MemoryDB is, next microservice deployment I go, definitely gonna be a piece of it for sure on my side.
Good. All right. So maybe John, you can talk to us about some key use cases when it comes to MemoryDB, right? We talked about how fast it is with all of these durability features, but are there some like key use cases when people use things like MemoryDB?
Yeah, it's kind of always hard to answer because well, think about all the different ways that Redis is being used today. Like it shows up in all sorts of things, ranging from on-demand ride sharing, figuring out, what in real time, where are the closest cars to where you are right now, delivery services, in real time, where are the closest things to me right now, and then using that information to make decisions to gaming leaderboards, at scale in real time, to IoT ingesting data from just tons of devices really quickly, and then being able to do kind of certain analytics functions and also certain operational functions on that information. Serving data incredibly fast for websites or applications that are just kind of, make an application, right? E-commerce. You're seeing a lot of this for FinServe, that sort of thing. And so there's just a ton of kind of things, and also just kind of message queuing, right? Redis has all these kind of cool queuing features. So, controlling communication between microservices is another big one that we're seeing kind of interest very early on in MemoryDB. So, I could kind of dive into each one of these for a while, but just the scope of where it is just huge. And so I think, the way that I think about it is that, if you've got a use case that you need fast performance, like really fast performance, high throughput, you've got, kind of a lot of interactions happening, and kind of you see how data structures can be easier to build a lot of this stuff with, that's a good candidate use case for using a system like MemoryDB. And, kind of as we see in Redis is the 5 years in a row most popular database, a lot of the world is figuring out that, the Redis API is a really easy way to build stuff. And I like things that are fast. I don't have to deal with a lot of the complexity around saying, hey, well, I got this thing to work at a small scale, but now that I've got, an exponentially higher number of devices or users or whatever, what do I do? The idea is that MemoryDB, you can start with it. It's easy to get started and build with Redis's APIs, but when you hit that kind of huge scale, it'll scale right with you. And so that's why we're super excited about it.
I wanna talk, and this is always, it's a new service. People may start using it quite soon. I want to talk pricing. Maybe not how much is it, but how pricing is.
Yeah.
What is the thing you're charging? What should we look out for when we're using MemoryDB? What's gonna cost us money? What's not gonna cost us money?
Yeah, great question. And I think pricing, try and be as transparent as possible, and more details and some examples are located on the pricing page on our website. But in a quick high level, it's pay for what you use. And so there's kind of 3 pricing dimensions you could say for MemoryDB. The first one is nodes. So when you create a cluster, you use 1 or more nodes. You don't pay for the nodes that you don't create. So you start creating a node, you pay by hour. And there's a couple of different node types. Actually, another thing that I bring up, we're super excited about, is MemoryDB is using AWS Graviton 2 instance types, which we in the kind of in-memory portfolio team and database services, we love Graviton 2. And the reason that we love Graviton 2 is because it really offers customers just a great price performance option that we see just customers coming and saying, yeah, we got up to 45% price performance increases off these instances. And there's no changes you need to do, just use that instance. And so MemoryDB, has Graviton, a variety of Graviton 2 instance types right now. We're supporting R6G, but you can expect that we'll be supporting more instance types options in the future. And you can create a cluster with 1 or more instances there. So you pay for that. And you can add and remove instances as your workload requirements change. So that's one dimension. Second dimension is data written. And so you get charged per gigabyte of data that you write, kind of a throughput dimension, into your cluster. But there's no associated charge for reads. So this is only really a kind of an I/O, write I/O related pricing charge. And then a final charge is for snapshot storage. Although we give you 1 free snapshot, which is basically like a snapshot with a 1-day retention for 100% of the data that you've stored in your cluster. So those are the 3 dimensions, and you can kind of see on the website, the instance characteristics of how much RAM and CPU and et cetera are there for each type.
Is there a free
tier?
tier?
Makes a lot of sense. Just thinking about it, there's enhanced durability now that does, however, come with a price of writes actually costing something to make sure that they've been durably synced to all of the nodes and across AZs. So maybe something to keep in mind is like what the read-write balance of your particular workload is when you're considering Elasticache versus MemoryDB.
I have a question here regarding, coming from what they call a DevOps background. If we're going to be launching developer versions of MemoryDB, right, something for an integration environment or a staging environment, can we launch like a non-durable single thing MemoryDB as well? Something cheaper, right? Is there an option to do that?
So right now, not. That's a good idea, and I think kind of we're open for feedback. We really want to know from all you listening too, of how you want to use this. What would you like to do if you can't do today? That's a good idea. Right now, there's not, and we do have an intention to support smaller instance types as well that might be more friendly for like dev environment. But because of Redis compatibility, you could use Elasticache node, which is basically kind of Redis in a non-durable way to test as well. We see people running kind of Redis containers locally, which is common, it's on your laptop. And then when you push it into a kind of more robust testing environment and eventually production, you're flipping over to like Elasticache for caching, or you would see MemoryDB. What are we trying to?
Okay, John, I was told that you were going to do a demo for us.
Yeah.
We would definitely love to see some demos. Before we get into that, Meadow, thank you very much. We haven't introduced Meadow. Meadow is our new ASL interpreter, so thank you very much for all you're doing. And we have to bring back Pam right now. So hello, Pam, once again. And John, I am going to bring in your demo right now.
Awesome. We're doing it live.
Of course. Whoops, wait. We need to do something here. Like this. Okay. I want to make sure Pam is visible. So please, John, tell us what you're going to show to us.
Cool. Yeah. And then it looks like the screen's up. So, yeah, well, I want to show you just a quick kind of overview of the console, run a couple Redis commands to show you a little bit, a little closer look at what we've been talking about. We've been talking more about what it does at a higher level, but we might as well just show you the actual service. So right now what you can see is created a cluster. Right now we're in the AWS console and the MemoryDB section of the AWS console in the cluster details page. And actually, we can see what we got. So this is kind of a list of clusters. I've got one cluster running. We click on it. It's called MemoryDB-cluster. And here you can see some of the cluster details, some of the features that we're talking about. I'll kind of go into some more of the details. Here you can see the node type. So R6G large, which is a Graviton2 instance type. And here you can see that we created a cluster with 2 shards. So the key space is distributed across 2 different instances. And each instance, or each node type, each shard has 3 nodes. And as you can see here, each node is in a different availability zone. So that's important. As I mentioned, when we're talking about data durability, there's this multi-AZ transactional log that keeps your data durable.
Okay.
That's different than kind of database availability that has more to do with, we're also storing all this in memory. That's where the reads are coming from. How many nodes do you have in different AZs that can serve that key space from memory? So in this example cluster, we've got 3 for each shard. So in the case that one of these nodes goes down, traffic is redirected. And in the same way with kind of Redis cluster, your client is hitting this configuration endpoint. And that's what you configure in the client. And then the client has the smarts to know if a new nodes comes up, registering that IP. So you don't have to kind of figure out all the endpoints for every single node. The configuration endpoint, your cluster together, handle kind of the complexity of figuring out when new nodes come online, when nodes say go away,
right.
What node has what key space, where's the primary node, and that sort of thing.
Is that endpoint actually leading to a load balancer or to some primary node, or what is it? Where is it actually leading to?
It's leading into some networking configuration on our side.
Okay.
Some of that there.
Gotcha.
So, networking security, Amazon MemoryDB is launching the VPC across, utilizing subnets and security groups, all of the kind of usual AWS networking and network security stuff you'd expect. I really like this page just because, CloudWatch metrics are just so important in understanding what's going on in your cluster. And we have a bunch of different metrics that are taking their time loading, it looks like right now. But a bunch of information on, how's my cluster doing? How much memory do I have? What's, kind of the throughput, a bunch of other things that are important here. And as you can see, each of the nodes are being tracked here utilizing CloudWatch metrics.
And just to be clear, I can create my alarms on this if I need to, and ping on call if there's a disaster going on with something in my cluster.
Yep. Same CloudWatch metrics as you come to expect from any standard AWS database service. And I kind of like the composite graphs that you can see. You can kind of pump those into other metrics and do math on it. The metrics math type stuff. There's a lot of things you can do. I know people get very clinical with those metrics as well. And so we're happy to provide that. And if we're missing a metric that's important, let us know. We'll try and get that supported.
Yeah,
Um,
alarms are important, so we need to be able to create alarms if things go awry. So as long as we have the right metrics, that's very good.
yeah, definitely. On this page, just to show kind of the maintenance stuff, one cool thing about MemoryDB is that we automatically manage all the maintenance, so patches and upgrades and everything else. Those are all done within maintenance windows or our service updates feature, where you can either have it automatically scheduled or run it at a time you want, with really no impact and downtime. So fully managed maintenance. As you can see here, my maintenance window is at this time. Right now, there's no pending updates to be notified of. Also, I've got a snapshot enabled. It's automatic, and it gets retained for a day. And there's a snapshot name. You can take obviously multiple snapshots and do more things with it. So those are some of the features. There's one more feature that I do want to bring up. I mean, parameter groups is kind of the tried and true thing that you're used to with RDS and everything else. Just a bunch of settings for Redis that you can change. But it's really this access control list. And so what an access control list is basically a way to easily configure users on your Redis MemoryDB, using the Redis access control list functionality, so you can have multi-tenant clusters. You can have a bunch of different users on a cluster. Each user has their own permissions, and it's a great way to segment different users, or oftentimes it's really just applications accessing this in like an operational sense, to make sure that there isn't kind of overlap and you can limit what you can do. And so it's super easy to create. Here's an example of the ACL list, the ACL that's on this cluster. There's two users, John and Zach. And here's the access string, which utilizes the same language that the Redis ACL kind of access control language uses. And I can easily add and remove users to this, edit permissions and all sorts of stuff, and then apply it to a cluster. And so the goal here, once again, is super important to have good authentication, authorization, controls, and experience for a database. And we think this is a great way to do that.
That's super fascinating. I'm already thinking about ways that I could take the IAM identity of a particular application, maybe it has its own IAM role, turn that into an ACL in the Redis cluster in order to say this service has access to this particular key space, but it doesn't have access to another key space.
Yeah, and you need to stitch it right now. The Redis ACL kind of feature set utilizes passwords. You can put the password in Secrets Manager, and we'll be writing some blogs, shortly on ways to do that. But it's a similar mechanism as you would use with Elasticache to go and do that. But over time, we'd love feedback on what other identity providers and systems, IAM and others, might be interested. Would you want to use to go and do this sort of stuff? So we'd love.
That was actually exactly what I was thinking. I was thinking about like doing the ECS task secrets, and then have the password as a secret that gets injected into the container, and then it can use that particular secret to authenticate as that user inside of the MemoryDB cluster. So the pieces are already there. Now that you have that ACL integration, now I have the ability to carve up that MemoryDB cluster into separate spaces that one service can talk to, another service can't. It's amazing.
Yeah. So we went through the console. If you wanted to, I'm showing you a cluster that's already created, but a lot of these features are kind of part of the configuration workflow that you would do if you went to go and create a new cluster, which you can do.
Yeah, let's see how that works. Yeah, I think that would be great to show people.
I guess we have a little bit of time. Yeah, so let me go back because I kind of jumped around. I got too excited here. From a variety of different things, you can click Get Started and then hit Create Cluster here, or you can go to just the cluster list page, hit Create Cluster. And you start it really with two options. If you think about it, this is kind of the decision point where you want to do one of two things. You either want to create a new cluster, it's brand new, or you might want to restore from an existing snapshot. As we talked about before, if I was, say, running Redis cluster on EC2 or on premises or wherever, and said, I really want to take advantage of the performance and manageability and the kind of durability of MemoryDB. I want to use that as a primary database, primary Redis database. Take a snapshot from what you're using before, and then restore it here. Obviously, there's some versioning things that you need to think about, and that's written in documentation. But it's at this point here where you can say, I want to restore, and I can restore from obviously a MemoryDB snapshot or a other snapshot, or create a new one. On this flow, the name of the cluster, the description, and we can even just do that right now.
While you're doing that, just kind of to address a couple of questions in chat. Adrian asked us, will there be a Q&A session at the end? Adrian, this is all a Q&A session. So if you have a question, please feel free to drop it in. And Styler asks, what's the difference between this and Redis? Well, we went over that, but basically this has Redis compatibility. So anything, well, most of the things you do on Redis, you can do here as well. We've determined that Redis modules are not supported, but yeah.
And the main difference is the fact that MemoryDB has enhanced durability compared to traditional Redis. When you do a write to MemoryDB, it's replicated, it's durably persisted, and it's not going to go away if you accidentally have a Redis server crash or disconnect from the network for some reason.
Yeah. Good answers. So real quick, so you pick your subnet group. There are cluster settings. The version of Redis right now we support 6.2, but we will be supporting new versions as they're released. The parameter group right now, we're using the default one. The node type, you can select a variety of different node types, each with a different amount of memory. Number of shards, we can just choose 1, I guess, for now, and replicas per shard, we'll say 2. So a very small cluster. And then moving forward, you can select a security group. In this case, we can select, there's a lot of security groups here. Default key, so MemoryDB encrypts your data at rest, and Graviton 2 instances actually also provide in-memory encryption as well by default. For encryption, you can use an AWS owned key, which is what we have. I could have created my own AWS KMS key, and I could have chosen to use that too if there was one here. Encryption transit TLS, we obviously recommend that you encrypt in transit. Also, to use the Redis ACL, you need to be encrypting as well. And then in this case, we'll use demo as the ACL. We'll keep snapshots enabled. We'll keep the retention period for 1 day. No preference on the time for that. Got no preference for maintenance window as well, the maintenance window time. For SNS notifications, we'll disable them for now, but you can enable them and get all sorts of information pushed to Amazon SNS about what's going on with your cluster. We won't put on any tags for now, although tags are pretty useful for billing. And then create it. Oops, and it looks like
subnet groups. And
that's a classic.
Admittedly, this is not my account, so I don't exactly know what VPC is what. But you guys get the idea.
We do have a couple questions. So there's
a
good question on what does it mean for a service to be GA, and when will MemoryDB be promoted from GA? My understanding is it's already GA, right?
Yeah, so, we're GA. We're prime time. So come on and give it a spin.
Yeah. So some services go through a preview period where we're still seeking feedback from customers on how the service is working, whether they have any issues with it. MemoryDB is GA already. It's out there. It's ready. It's ready for you. And an interesting question from Twitch: is there a MemoryDB VPC endpoint available to use private IP traffic when communicating with it?
So I believe the endpoints that we provide are within VPC. So we have to take that offline because I like the cluster endpoint. All the nodes are running within a VPC, and so I think the answer is
it looked to me like the cluster endpoint is already in the VPC. So even if I have a fully private subnet, I could have my tasks inside that private subnet communicating to the MemoryDB endpoint. I wouldn't have to go traverse the public internet for that. So it should already be private traffic.
Yep, that's correct.
Another one, does MemoryDB from Christian, does MemoryDB support auth by IAM, or do we still need that DB password?
Great question. So, there's a bunch of different things from an authentication point of view. So I'll answer that question, but also another one just to be kind of complete. So the management APIs for MemoryDB, like create a cluster, resize a cluster, delete a cluster, all of those are authenticated via IAM users roles, principles. For access in the to the Redis commands on your cluster, that right now is using the Redis ACL, and that right now only supports passwords. Now you can store the password in Secrets Manager. There's some things you can do with that, but that's currently the authentication mode, username, password for those users that are on the cluster.
Awesome. Thank you all for the questions. This is amazing. John, you were about to show us something here on this command line.
Yeah, it was just this is the grand finale. So I showed you that cluster that was running. And so using Cloud9, I've connected to it, as you can see already. And so the first step of what I'm going to do is I'm going to authenticate as, remember those users, there was John and Zach. So that's basically the authentication command. So my client that was running, my Redis CLI that was running in Cloud9, is hitting the cluster endpoint, and I've authenticated as myself. And now I can do stuff. So I can set value. Let's re-authenticate. Sometimes Cloud9 does some odd things in my environment that I've set up. There we go. So set A, we can get A, 100. So it's working. And then we can do some cool things, like we can use kind of Redis sorted sets. We can create a sorted set called my sorted set and add, a couple of keys and weights, basically data and weights. Oops. So here we've created a sorted set with 3 entries: 100A, 200B, 201C, which is the relative weights. And then if we want to then return that, we'll come back in order. And if we wanted to say add another one in the middle just for fun, so we can say we can add one with a weight of 150. Call it AA. Insert that into the sorted set. That same command that we ran before will now reorder all those, even though the order that we put them in, obviously, we put in 150 AA last. As you can see here, AA is sorted in the correct order. And so that's kind of a very, very, very simple kind of demo. But as you can see, imagine you had a huge, huge, huge number of entries, like a leaderboard, that you needed to keep in order. You don't have to write any kind of custom logic to insert things in the right way. That's just kind of inherent in what a sorted set does. It keeps it sorted. So there's a bunch of other commands. This is just the very tip of the iceberg. But as you can see, super easy to connect. I authenticated as myself. All of a sudden started working with Redis, and kind of under the hood, you've got MemoryDB, which is storing your data durably, and offering you just incredible performance when building these applications.
That's awesome. I'm already ready to code my online game that has like a ranking system and like global leaderboard and everything. I'm good to go now. I got everything I need.
Excellent. Thank you, John. One important question, again, coming from an ops person like myself. Do you support CloudFormation?
So CloudFormation just ruined your weekend. CloudFormation is coming very, very soon.
Of course,
keep working on that. Obviously, we understand how important that is for operations perspective, and so we will announce when that's available. It's coming quite soon.
So make sure to look on the lookout for your CloudFormation template elements and CDK and all the fun infrastructure as code parts for MemoryDB. So, John, thank you very much for showing us Amazon MemoryDB. It's Amazon MemoryDB naming standards. Amazon MemoryDB, more durable Redis implementation on AWS. I hope I said it okay. So thank you very much for this wonderful demo. And this feature is available in 4 regions: North Virginia, Dublin, Mumbai. I said Bombay for some reason. I apologize to our Indian folks. It's Mumbai, and in Brazil, in Sao Paulo. So Thank you very much, John.